Okay, hi everybody. So what we're going to be talking about today is what happens when we have an action potential that's traveling down a myelinated axon. Now, if you notice, I made a video called Action Potential, and that's going to show you what happens when we have an unmyelinated axon. In this case, we're going to talk about what's happening when it's myelinated. So let's review real fast. So what happens, if you recall, in the action potential video, we said that when we get the inside of an axon up to negative 55 millivolts, or actually it happens at the axon hillock, we get up to negative 55 millivolts, the sodium gates would open, sodium would rush in, sodium gates would close, potassium gates would open, potassium rushes out, potassium gates close, sodium gates open, sodium rushes in, sodium gates close, then the potassium gates open, potassium rushes out, then the potassium gates close, then the sodium gate opens, sodium rushes in, and then sodium rushes out. And then potassium rushes out, and the gates close. So you can see that's a lot of that's kind of a lot. That takes a long time to travel down the axon. This is what an unmyelinated axon would look like. So now we want to talk a little about what happens when we have myelin. First of all, myelin is made up basically of fats, and I'm going to put some myelin in here. I'll put some right here, and I'm going to put some right here. And if you notice, I'm leaving the axon exposed there. The reason I'm doing that is because I want you to realize that we still have the axon going through the middle of the myelin. So this is myelin right here. That's my myelin. And this is myelin, and this is myelin, like we've already said. And then the space between the myelin is technically its unmyelinated axon. But we call this space that's here the nodes of Ranvier. Okay, so there's our nodes of Ranvier. And again, I'm only pointing to this one, but it's all of these, okay? So normally what happens in an unmyelinated fiber, like I showed you, these open and close, open and close, open and close. And so my impulse has to travel down the whole axon. What happens when we have myelin is technically it skips over the myelin and travels much faster. Now when it's an unmyelinated fiber, it travels at about 2 miles per hour. And when it's myelinated, it can travel between 40 and 300 miles per hour, depending on what books you read. All books say something different, but you can see it's much faster. That's the main point we want to get. So what we're going to do is we're going to take this unmyelinated fiber now, this unmyelinated axon, and we're going to pretend now that it has myelin on it. So I am going to take off this part right here and just make this like this. Okay, you see we have a big gap in here now. And then I am going to take this here and pretend like this is wrapped around the axon. So here's my myelin here. This is the myelin. And what's going to happen is I'm going to have the axon still passing through the myelin. Okay, and I know I've drawn it where it looks like it's actually inside the myelin. I'm just trying to show it that it's covering it. So what's going to occur here is when sodium gates open, like we mentioned, sodium rushes into the cell with its positive charges. So here comes my sodium. Okay. Now, what's going to happen is because the inside of this is basically negative, some of the sodium is going to spread out. So my sodium is going to spread out, and I'm going to actually have it come in here, all the way down in here. So I'm on the axon, but I'm basically on a part of the axon that is surrounded by myelin. So this part right here, pretend like it's right there on this. And then this here would be where the myelin is. And then this node of Ranvier here would be this part that's back over here. So what's going to happen is as sodium comes into this axon, it spreads out. And so I'm going to have some sodium that's in the axon in the myelinated part. So as it comes in, the sodium starts hitting each other. Or you can just say positive charge, but the sodium starts hitting each other, and it's kind of like the domino effect, where one just hits the next, hits the next, hits the next. When we get to the end of the myelin, what's going to happen is it's going to cause this sodium gate to open, and my signal is going to continue going down until it gets to another area of the axon to where I have myelin again. Then this occurs again. So sodium comes in, right? My sodium gate's open, sodium comes in. As it rushes in, it has a domino effect because it's spreading out and pushes sodiums down, right? And then what's going to happen is when it gets to this end, back to the node of Ranvier, because this would be a node of Ranvier here, because of the fact that I have no myelin there. And then what's going to happen is the impulse is going to continue until it gets to another area where there's a myelin. So that, which would be right here. Then it's going to do this again, where it pushes the sodium. It gets to the next node of Ranvier. Sodium gates open, potassium gates open, the whole thing continues on. And it's going to do that all the way down the axon. So that's basically it for how myelinated fibers work.